Welcome, sleepy travelers, to another gentle journey with the Boring Science Channel. Whether you've arrived here seeking rest after a long day, or simply find comfort in the quiet mysteries of our cosmos, you've found exactly the right place. Tonight, we're drifting through space and time to examine something that appeared in our skies not so long ago. Something that has left astronomers scratching their heads and asking uncomfortable questions. It's called 3I Atlas, and it might just represent the most unsettling visitor we've ever encountered. Before we begin this soft exploration into the unknown, I'd love to know where in the world you're listening from tonight. Are you nestled under blankets in London as the rain taps against your window? Perhaps you're watching the stars from a quiet porch in rural Montana. Or maybe you're somewhere in between, letting the day's worries fade away as we embark on this cosmic contemplation together. If you find these nighttime journeys soothing, I'd be genuinely grateful if you tap that like button and subscribe to join our growing community of sleepy stargazers. Now, I do hope this exploration isn't too captivating to keep you awake, though if it does, at least you'll drift off with some fascinating cosmic knowledge swirling through your thoughts. So, settle in, let your breathing slow, and allow yourself to float alongside me into the depths of space, where something extraordinary and possibly quite troubling has been making its way through our solar system. Sometimes, the most significant discoveries announce themselves not with fanfare, but with whispers. In the quiet halls of observatories around the world, astronomers spend their nights cataloguing the movements of distant objects, tracking the slow dance of asteroids and comets that populate the space between worlds. Most of these celestial wanderers follow predictable patterns, their orbits traced and their futures mapped with mathematical precision. But occasionally something appears that doesn't quite fit the established patterns, something that makes scientists pause and look more carefully at their data. Such was the case when telescopes first detected what would eventually be designated 3I Atlas. At first glance, it seemed unremarkable enough, just another point of light moving against the backdrop of stars. But as astronomers began calculating its trajectory, something unusual emerged. This wasn't just another asteroid or comet bound to our sun. The mathematics revealed a hyperbolic path, the unmistakable signature of an interstellar visitor, an object that had journeyed from beyond our solar system. This designation, 3I, marked it as only the third confirmed interstellar object ever detected by humanity. The first, 1I Oumuamua, had caused quite a stir when it passed through in 2017, with its unusual elongated shape and mysterious acceleration. The second, 2I Borisov, appeared more conventional, resembling a typical comet with its glowing tail, though it too carried mysteries in its chemical composition. Now came Atlas, and from the very beginning, it seemed determined to challenge our understanding in ways both subtle and profound. The speed at which Atlas was traveling immediately caught attention. With a hyperbolic excess velocity exceeding 60 kilometers per second, it was moving faster than most natural objects should be able to travel if they were simply ejected from another star system through ordinary planetary interactions. To put this in perspective, this object was covering distances in seconds that would take our fastest aircraft minutes to traverse. Such velocity suggested either an extremely energetic ejection process or something else entirely. But speed was only the beginning of Atlas's peculiarities. When powerful telescopes like the James Webb Space Telescope turned their attention to this visitor, they revealed a chemical composition that defied easy categorization. Unlike the comets in our own solar system, which typically show strong signatures of water ice, Atlas was dominated by carbon dioxide in proportions that seemed almost alien. The ratios of various compounds didn't match anything astronomers had seen before, suggesting formation in an environment vastly different from the conditions that shaped objects in our local neighborhood. This chemical oddity raised immediate questions about the object's origin. If Atlas had indeed formed in another star system, what kind of environment could have produced such an unusual composition? The dominant presence of carbon dioxide over water suggested conditions unlike anything we observe around our own sun. Perhaps it formed in the outer reaches of a system much colder than ours, or possibly closer to a star under different radiation conditions. Each possibility strained conventional models of how planetary systems develop. The size of Atlas presented yet another puzzle. Determining the actual dimensions of distant comets is notoriously difficult, as they shroud themselves in clouds of gas and dust that can extend for thousands of kilometers beyond their solid nucleus. Current estimates placed Atlas somewhere between a few hundred meters and several kilometers across, an uncertainty that represented the difference between a large boulder and a small mountain. This ambiguity wasn't merely an inconvenience for astronomers, it was fundamental to understanding how such an object could survive its journey. Small objects, the thinking goes, should not be able to endure the violence of interstellar space for billions of years. The constant bombardment by cosmic rays, impacts from dust grains traveling at tremendous speeds, and the erosive effects of radiation should gradually wear away anything too small to protect itself. Yet here was Atlas, showing signs of active outgassing despite having potentially wandered through the galaxy for eons. How had something so seemingly fragile managed to preserve volatile materials across such vast spans of time and space? The trajectory calculations added another layer of mystery. When astronomers traced Atlas's path backward through the galaxy, they found that it likely originated not from the thin disk of stars where our sun resides, but from the thick disk, a much older population of stars that formed when the Milky Way was young and chaotic. This meant Atlas could be older than our entire solar system, a traveler from an epoch when the galaxy was a more violent and turbulent place. The implications of such ancient origins were staggering. If Atlas truly came from the thick disk, it had survived conditions that should have been far more hostile than anything objects in our solar system had ever faced. The early galaxy was filled with more frequent supernovae, more intense radiation fields, and more chaotic stellar encounters. For a small icy body to emerge intact from such an environment and arrive in our neighborhood billions of years later seemed to push the boundaries of what natural processes should allow. As weeks passed and more observations accumulated, the anomalies continued to mount. The object's brightness remained surprisingly stable, lacking the variations that astronomers typically see as rotating comets present different faces to the sun. Its outgassing patterns didn't follow the expected models for how ice should sublimate when heated. Even its silence in radio wavelengths, while not entirely surprising for a natural object, added to the growing sense that Atlas didn't quite fit into any familiar category. Some researchers began to whisper questions that few wanted to voice openly. Could this object be something other than a natural comet? The thought seemed almost absurd, yet the accumulating evidence made it increasingly difficult to ignore. Each measurement that came back from telescopes around the world seemed to add another piece to a puzzle that refused to resolve into a comfortable, familiar picture. The scientific community found itself in an uncomfortable position. The conservative explanation remained that Atlas was simply a comet with unusual but not impossible characteristics. Perhaps it represented chemistry from a type of star system we'd never studied before. Perhaps its survival was unlikely but not impossible. Perhaps the anomalies were simply the result of processes we didn't yet fully understand. Yet beneath these rational explanations lay a growing unease. The timing seemed almost too convenient. Here was humanity, just reaching the technological capability to detect and study interstellar visitors, and within the span of less than a decade, 3 such objects had appeared. Were we simply fortunate to live during a period of increased interstellar traffic, or was there something more deliberate about this timing? The possibility that Atlas might be artificial, that it might represent technology rather than natural ice and rock, introduced scenarios that were both fascinating and deeply unsettling. If it was some kind of probe or monitoring device, what would that mean for humanity's place in the cosmos? Were we being observed by intelligences we couldn't comprehend? Were we being catalogued, studied, perhaps even judged by criteria we couldn't imagine? These questions lingered in the background of every scientific paper, every conference presentation, every late-night discussion among researchers. The data supported natural explanations, but it also left room for doubt, for speculation, for the uncomfortable possibility that our first confirmed contact with technology from beyond our solar system might have already occurred, disguised as something we expected to see. As Atlas continued its swift journey through our cosmic neighborhood, approaching its closest point to the sun before beginning its inevitable departure back into interstellar space, astronomers raced to gather every possible piece of information. They knew their window of opportunity was limited. Soon, this mysterious visitor would fade beyond the reach of even our most powerful telescopes, taking its secrets with it into the vast darkness between the stars. But the questions it raised would remain long after its departure, echoing through observatories and research institutions around the world. What was Atlas, really? Where had it come from? And perhaps most unsettling of all, what did its presence in our solar system mean for the future of humanity? Tonight, as we begin this gentle exploration of these mysteries, we invite you to consider the profound implications of this strange visitor from the depths of space. What if the object we've been studying as a comet is something else entirely? What if its journey to our solar system was not random chance, but purposeful navigation? And what if the worst-case scenarios surrounding Atlas reveal truths about our universe that we're not quite ready to confront? The silence surrounding Atlas proved to be just as puzzling as its other characteristics. When radio telescopes around the world turned their vast dishes toward this interstellar wanderer, they listened across countless frequencies, scanning for any hint of artificial signals or structured transmissions. The result was absolute quiet. Nothing but the gentle hiss of cosmic background radiation and the natural emissions one would expect from sublimating ice and dust. For many scientists, this silence provided comfort. After all, comets don't typically broadcast radio signals, and the absence of any technological signatures seemed to support the natural explanation. Yet for others, the very completeness of this silence began to feel unsettling in its own way. In a universe where even natural processes often produce detectable electromagnetic emissions, Atlas seemed almost deliberately quiet, as if it were carefully avoiding any behavior that might seem artificial. This raises a fascinating and somewhat disturbing possibility. If an advanced civilization wanted to send probes through star systems without detection, wouldn't silence be their first priority? Any artificial signal would immediately betray the probe's true nature, potentially causing panic or triggering defensive responses from the civilizations it encountered. The most effective surveillance device would be one that appeared completely natural, indistinguishable from the cosmic debris that regularly drifts between the stars. The concept of disguise in nature isn't foreign to us. Here on Earth, countless species have evolved elaborate camouflage strategies, mimicking leaves, rocks, or even other animals to avoid detection by predators or prey. If evolution can produce such sophisticated deception on a single planet, what might intelligence achieve on a galactic scale? A probe designed to look like a comet would have the perfect cover, allowing it to pass through system after system, gathering information while its observers dismiss it as nothing more than interesting but harmless debris. This line of thinking leads us into what researchers quietly call the disguise hypothesis. Under this scenario, Atlas isn't a random fragment of ice and rock that happened to wander into our neighborhood. Instead, it's a carefully engineered construct, designed to mimic the appearance and behavior of a natural comet while serving an entirely different purpose. The unusual chemistry that puzzles astronomers becomes not an anomaly of formation, but a feature of design. The improbable survival across billions of years becomes not a stroke of luck, but evidence of robust engineering. The convenient timing of its arrival becomes not coincidence, but scheduling. If we accept this possibility, even as speculation, it transforms our understanding of what we're witnessing. The coma of gas and dust surrounding Atlas's nucleus would serve as perfect camouflage, concealing any artificial structures or systems within. The outgassing that we interpret as natural sublimation could actually be controlled venting, designed to maintain the illusion while potentially powering hidden instruments or adjusting the object's trajectory in subtle ways. The implications stretch far beyond mere scientific curiosity. If Atlas is indeed artificial, then we're not just observing a visitor from another star system, we're potentially being observed in return. Every telescope we point at the object, every spectrum we analyze, every paper we publish about its properties becomes part of the data it might be collecting about us. Our very act of studying it could be revealing information about our technological capabilities, our scientific methods, our level of development as a civilization. This possibility becomes even more unsettling when we consider the timing of Atlas's arrival. Humanity has only recently developed the capability to detect and track interstellar objects. Our radio emissions have been leaking into space for less than a century, and our artificial satellites have been orbiting Earth for only decades. If probes like Atlas are designed to monitor emerging civilizations, then our current moment in history represents exactly when such a visit might be expected. We've become visible to the galaxy just as these mysterious visitors begin appearing in our skies. The chemical composition of Atlas takes on new significance under this interpretation. Rather than representing the exotic chemistry of an alien star system, the unusual ratios of carbon dioxide to water might be carefully chosen to create a believable but anomalous signature. Too familiar, and the object might be dismissed as ordinary. Too strange, and it might trigger immediate suspicion of artificial origin. The chemical fingerprint we observe could be calibrated to generate scientific interest while remaining plausibly natural. Even the object's trajectory becomes suspect when viewed through this lens. The hyperbolic path that carries Atlas through our solar system provides the perfect balance of access and escape. It passes close enough to observe our planet and sample our electromagnetic emissions, yet maintains sufficient speed to ensure it cannot be intercepted or detained. If we wanted to send a probe through an alien system, we might choose a very similar approach, close enough to gather data, fast enough to avoid entanglement. The size uncertainty that frustrates astronomers trying to characterize Atlas could itself be intentional. A probe designed to remain ambiguous would benefit from being neither obviously small nor obviously large. Too small, and its survival becomes implausible. Too large, and its rarity becomes suspicious. The current range of estimates places Atlas in a convenient middle ground, where both natural and artificial explanations remain viable. Perhaps most intriguingly, the object's origin in the galactic thick disk adds another layer to the mystery. If Atlas represents technology rather than natural debris, then its ancient stellar neighborhood suggests origins in a civilization far older than our own. The thick disk population dates back to the early days of our galaxy, when star formation was more chaotic and heavy elements were scarcer. Any intelligence that emerged from that environment and survived to develop interstellar travel would possess a technological heritage spanning billions of years. This raises profound questions about the nature of such ancient civilizations. How does intelligence persist across such vast timescales? What motivates a species to launch probes that will travel for eons before reaching their destinations? What kind of patience does it require to design missions that span geological ages? If Atlas truly represents technology from the thick disk, then we might be witnessing the product of a civilization so old that it predates complex life on Earth. The possibility that we're being studied by such ancient intelligence is both humbling and terrifying. From their perspective, human civilization would appear as a brief flicker, a species that has only recently learned to harness electricity and is just beginning to explore beyond its home planet. We would be juveniles in their eyes, perhaps interesting as a case study but hardly threatening or even particularly noteworthy. Yet the very act of sending probes suggests that even ancient civilizations find value in observing younger species. Whether this interest stems from scientific curiosity, strategic planning, or something else entirely remains unknowable. Are we being catalogued as part of a galactic survey? Are we being evaluated for some future purpose? Or are we simply one data point among countless others in a vast, ongoing study of how intelligence emerges and develops throughout the cosmos? The silence of Atlas becomes even more meaningful in this context. If it truly is an observer from an ancient civilization, then its lack of communication might be deliberate policy rather than natural limitation. Perhaps long-lived species learn that direct contact with younger civilizations creates more problems than it solves. Perhaps they've discovered that observation without interference provides better data about natural development patterns. Or perhaps they've concluded that most emerging species aren't ready for the knowledge that they're being watched. This interpretation suggests that the galaxy might be far more structured and organized than we imagine. Rather than a chaotic collection of isolated worlds, it could be a carefully monitored environment where the development of new civilizations is tracked and recorded by older, more established intelligences. The apparent emptiness we observe when we search for signs of extraterrestrial life might not indicate absence, but rather the success of a galaxy-wide policy of non-interference and concealment. If this scenario reflects reality, then humanity finds itself in a position that's both privileged and precarious. We're advanced enough to detect these visitors, yet not advanced enough to understand their true purpose or capabilities. We're being studied by intelligences we cannot comprehend, using methods we can barely perceive. The cosmic loneliness that has characterized human existence might be an illusion, maintained by watchers who observe us from within perfect disguises. As Atlas continues its journey toward the inner solar system, approaching the point where solar heating will intensify its outgassing and potentially reveal more about its true nature, we're left to contemplate these unsettling possibilities. The object that initially appeared as an interesting but harmless comet might represent our first glimpse of technology so advanced that we mistake it for nature itself. And if that's the case, then the worst-case scenarios we're exploring aren't just theoretical exercises. They're potential realities that could reshape our understanding of our place in the universe and our future as a species. The questions multiply rather than resolve. If Atlas is watching us, what does it see? If it's recording our behavior, what conclusions might it draw? And if it's part of a larger network of such observers, what does our detection of it mean for the cosmic game of hide and seek that might have been playing out around us for far longer than we've realized? The orbital mechanics of Atlas tell their own haunting story. When astronomers calculated its precise path through space, they discovered something that should have been impossible for a natural object of its apparent size and composition. The trajectory wasn't just hyperbolic, indicating an interstellar origin, but it traced back to regions of our galaxy that shouldn't have been able to produce stable, long-lived comets. As you drift deeper into sleep tonight, consider this puzzle. The thick disk of our galaxy, where Atlas appears to have originated, represents a stellar neighborhood that formed when the Milky Way was young and violent. Stars in this region move differently than those in our local area, following orbits that carry them high above and below the galactic plane. They're older, metal-poor, and surrounded by environments that should have been hostile to the formation and preservation of small, icy bodies. Yet somehow, Atlas emerged from this ancient chaos, intact and active after what could be billions of years of wandering. The survival statistics alone strain credibility. Small objects in interstellar space face constant bombardment from cosmic rays, dust grains traveling at tremendous velocities, and radiation that should gradually strip away their volatile components. The fact that Atlas arrived in our solar system still capable of producing a visible coma suggests either extraordinary luck or extraordinary design. The timing of its arrival adds another layer of unease to this cosmic puzzle. Humanity has only recently developed the technological capability to detect objects like Atlas. Our first confirmed interstellar visitor, Oumuamua, was discovered in 2017. Borisov followed in 2019. Now Atlas appears in our telescopes, making it 3 such detections in less than a decade. The statistical models that predicted these discoveries suggested they should be rare events, perhaps once-in-a-century occurrences. Instead, we're seeing them with a frequency that makes astronomers quietly revise their estimates upward. This clustering raises uncomfortable questions. Are we simply witnessing a natural phenomenon that's more common than previously believed? Or could there be something more deliberate about this timing? If advanced civilizations exist and monitor emerging species, they might time their observations to coincide with technological thresholds. The moment a species develops the ability to detect interstellar visitors could represent the optimal time for surveillance, when they're advanced enough to notice, but not yet capable of meaningful interference. The chemical signature of Atlas becomes even more intriguing when viewed through this lens. The dominance of carbon dioxide over water represents more than just an unusual formation environment. It suggests conditions so different from our solar system that they challenge our understanding of how planetary systems develop. But there's another possibility that's harder to dismiss. If you were designing a probe to mimic a natural comet, you might choose volatile compounds that create believable outgassing while serving other functions. Carbon dioxide sublimes at lower temperatures than water ice, meaning activity begins farther from the sun. This creates an expanding shroud of gas and dust that conceals the nucleus long before any detailed observations become possible. From an engineering perspective, it's an ideal camouflage material. It provides cover when you need it most, generates the spectral signatures observers expect to see, and creates enough of an anomaly to spark scientific interest without triggering immediate suspicion of artificial origin. The size ambiguity surrounding Atlas serves similar purposes. Current estimates place its nucleus somewhere between a few hundred meters and several kilometers across, an uncertainty range that represents the difference between a city block and a small mountain. This vagueness isn't accidental. The coma that makes size determination difficult also makes detailed structural analysis impossible. We can observe the overall brightness, track the general motion, and analyze the chemical composition of the gases being released. But we cannot see the actual object hidden within that glowing envelope. If Atlas were artificial, this concealment would be perfect. The very phenomenon we expect from natural comets, the formation of a coma as solar heating releases volatile materials, becomes an impenetrable veil. Whatever lies beneath could be smooth ice or complex machinery, solid rock or sophisticated instruments. The disguise is self-maintaining and completely plausible, requiring no active effort to sustain. The speed at which Atlas travels through our solar system also serves multiple purposes, whether natural or artificial. At over 60 kilometers per second, it's moving too fast for any current human spacecraft to intercept. Even if we launched a mission the moment we detected it, the object would be gone long before any probe could reach it. This velocity ensures that our observations remain limited to distant spectroscopy and imaging. We can watch, but we cannot touch. From a strategic perspective, such speed provides the perfect balance of access and security. The object passes close enough to Earth to observe our electromagnetic emissions, sample our atmospheric composition, and monitor our technological signatures. Yet it maintains sufficient velocity to guarantee escape, regardless of how we might choose to respond. It's close enough to study us, fast enough to avoid entanglement. The radio silence that characterizes Atlas adds yet another piece to this unsettling puzzle. When sensitive receivers scan its position across multiple frequencies, they detect nothing but the natural emissions expected from sublimating ice and cosmic background radiation. This quiet could indicate that the object is indeed natural, lacking any artificial systems that might betray technological origin. But it could equally suggest sophisticated design, carefully engineered to avoid detection. Advanced civilizations would understand that electromagnetic emissions travel at light speed and can be detected across interstellar distances. Any probe operating in stealth mode would necessarily maintain complete radio silence, communicating only when absolutely necessary, and then perhaps through methods we cannot monitor. The absence of signals becomes not evidence of naturalness, but proof of competence. This possibility transforms every aspect of our interaction with Atlas into something more complex than scientific observation. If the object is watching us, then our very act of studying it becomes part of the data it collects. Every telescope we point in its direction, every spectrum we analyze, every paper we publish reveals information about our technological capabilities, our scientific methods, our level of coordination as a species. We cannot know what conclusions such an observer might draw from watching our response. Are we behaving as expected for a species at our level of development? Do our detection methods suggest rapid technological progress or concerning military applications? Does our scientific curiosity indicate promising intelligence or dangerous unpredictability? The questions multiply endlessly because we cannot see ourselves from the outside, cannot understand how our actions might be interpreted by intelligences with entirely different perspectives and vastly longer experience. The possibility that Atlas represents our first encounter with extraterrestrial technology, disguised as a natural phenomenon we're comfortable dismissing, carries implications that extend far beyond astronomy. It suggests that first contact might not arrive as dramatic revelation, but as subtle infiltration. That the universe might be far more structured and monitored than we imagine. That humanity's cosmic isolation could be an illusion maintained by watchers skilled enough to observe without being observed. If such surveillance exists, it raises profound questions about agency and development. Are we following a natural path of technological and social evolution, or are we being subtly guided along predetermined routes? Do our choices matter in a cosmos where advanced intelligences might intervene to prevent certain outcomes? The very act of being watched changes the nature of being watched, introducing uncertainties that no amount of self-reflection can resolve. As Atlas approaches its closest point to the Sun, solar heating will intensify the outgassing that creates its protective coma. Paradoxically, this might make the object even more difficult to study, as increased activity generates thicker veils of gas and dust. If timing were deliberate, this represents perfect planning. Maximum concealment occurs precisely when human interest peaks, ensuring that our most intensive observations yield the least definitive results. The departure of Atlas will leave us with questions rather than answers, speculation rather than certainty. Whether it represents exotic natural chemistry or sophisticated artificial design, whether its arrival was cosmic coincidence or calculated timing, whether its silence indicates absence or presence of intelligence, all will remain unresolved. The ambiguity itself might be the message, a reminder that the universe contains mysteries we're not yet ready to solve and watchers we're not yet able to recognize. Tonight, as this strange visitor continues its swift passage through our cosmic neighborhood, we're left to contemplate possibilities that challenge our most fundamental assumptions about our place in the galaxy. The object we initially catalogued as an unusual but harmless comet might represent our first glimpse of intelligence so advanced that we mistake its technology for nature itself. And if that's true, then the worst-case scenarios we're exploring aren't merely theoretical exercises. They could be glimpses of a reality we're only beginning to perceive, one where humanity's splendid isolation has been an illusion all along. The prospect of Atlas carrying biological material introduces scenarios that shift from unsettling to genuinely terrifying. Throughout our planet's history, life has demonstrated remarkable resilience, surviving in environments once thought impossible. Extremophiles thrive in boiling water, acidic pools, and the vacuum of space itself. If microorganisms can endure such harsh conditions on Earth, what might survive the billion-year journey between stars, protected within the icy heart of an interstellar wanderer? This possibility opens the door to what scientists call panspermia, the theory that life spreads throughout the universe via comets, asteroids, and other celestial messengers. In its most benign form, panspermia suggests that the building blocks of life, organic molecules, and perhaps even primitive microorganisms, travel naturally between worlds, seeding new biospheres wherever conditions prove suitable. Under this scenario, life throughout the galaxy might share common ancestry connected by an invisible network of biological exchange spanning millions of years. But panspermia need not be natural or benign. If Atlas represents technology rather than random debris, then its biological cargo could be deliberately chosen and carefully preserved. What we interpret as natural outgassing might actually be controlled dispersal, releasing microscopic payloads designed to alter planetary environments in subtle but profound ways. The chemical signatures we measure in its coma could mask biological agents so small and so alien that our instruments cannot detect them, recording them merely as dust or contamination. The implications of deliberate biological seeding stretch far beyond scientific curiosity into realms of existential concern. If advanced civilizations possess the technology to engineer and deploy biological agents across interstellar distances, then every comet that passes through our solar system becomes a potential vector for contact that we neither recognize nor control. The cosmic debris that has been striking Earth for billions of years might carry more than just water and organic compounds. It might carry instructions, written not in radio signals or mathematical equations, but in the universal language of genetics itself. Consider the possibility that life on Earth didn't arise through purely natural processes, but received crucial assistance from previous visitors like Atlas. The sudden appearance of complex molecules necessary for life, the improbable timing of certain evolutionary leaps, the mysterious origins of consciousness itself, all could represent not random chance, but careful cultivation. If our biosphere has been shaped by external influence, then humanity might not be the product of terrestrial evolution alone, but part of a galactic biological network whose purpose we cannot comprehend. This scenario becomes darker when we consider that biological agents need not create life. They could just as easily prevent it or redirect it along paths chosen by their designers. A civilization seeking to eliminate potential competitors might develop organisms that appear harmless initially but gradually undermine the stability of targeted ecosystems. Such agents could remain dormant for generations before activating, triggered by specific environmental conditions or population thresholds. By the time their effects became apparent, containment would be impossible. The timing of Atlas's arrival takes on ominous significance in this context. If it carries biological cargo, then its passage through our solar system occurs precisely when humanity has developed global industrial civilization, when our electromagnetic emissions announce our presence to the galaxy, when our population and technology have reached levels that might trigger concern among older intelligences. The coincidence feels less like chance and more like response, as if our development has crossed some threshold that demands intervention. Even more troubling is the possibility that such intervention has occurred before, multiple times throughout Earth's history, each event carefully timed to influence evolutionary development in desired directions. The mass extinctions that punctuate our planet's biological record might not result from asteroid impacts or volcanic activity alone, but from periodic adjustments carried out by visitors we never recognized as artificial. Each extinction creates opportunities for new forms of life to emerge, potentially guided by biological agents introduced during previous passes. The chemical composition of Atlas supports these darker speculations. The unusual dominance of carbon dioxide over water suggests not just exotic formation conditions, but potentially exotic purposes. Carbon dioxide provides an ideal medium for dispersing biological agents, creating expanding clouds that can reach planetary atmospheres while appearing completely natural to observers. The gas itself becomes both camouflage and delivery system, concealing payloads within phenomena we expect to see from comets. The size uncertainty surrounding Atlas's nucleus adds another layer of concern. If the object were designed to carry biological cargo across interstellar distances, it would need to be large enough to preserve that cargo against cosmic radiation and impacts, yet small enough to avoid attracting excessive attention. The current range of estimates places it squarely within parameters that would satisfy both requirements, neither too small to maintain biological integrity nor too large to appear suspiciously artificial. The radio silence that characterizes Atlas becomes even more significant when viewed through the lens of biological warfare. Any civilization deploying such weapons would ensure they operated without detectable signatures, appearing as natural phenomena to prevent defensive responses. The complete absence of artificial emissions doesn't prove the object is natural. Instead, it suggests either naturalness or extremely sophisticated design, making the distinction impossible to resolve through observation alone. Perhaps most disturbing is the realization that if Atlas represents biological intervention, we might already be too late to prevent its effects. Comets begin outgassing long before they reach the inner solar system, releasing materials across millions of kilometers of space. Earth's orbit carries us through this dispersed material whether we recognize it or not, exposing our planet to whatever microscopic passengers might be riding along. Even if Atlas proves to be entirely natural, the precedent it establishes is deeply unsettling. Future visitors might carry less benign cargo, and we would have no way to distinguish threat from curiosity until consequences became apparent. The biological scenarios surrounding Atlas force us to confront humanity's fundamental vulnerability in cosmic terms. We exist on a single planet, protected by a thin atmosphere, dependent on biological systems we barely understand. Any disruption to these delicate balances could cascade through our entire biosphere, altering the conditions that sustain not just human civilization, but complex life itself. We cannot filter space, cannot quarantine our planet against microscopic invaders, cannot even detect biological agents designed to remain hidden. This vulnerability extends beyond immediate survival to questions of identity and autonomy. If Earth's biosphere has been shaped by external intervention, then what aspects of human nature represent authentic development versus imposed direction? Our curiosity's traits have been encouraged or suppressed by biologicality, our aggression, our tendency to explore and expand, co-agents working over evolutionary timescales. The possibility that we are not entirely self-determined undermines our most basic assumptions about consciousness and free will. The worst-case biological scenarios don't require malicious intent from Atlas's hypothetical creators. Even well-meaning intervention could produce catastrophic results if those intervening lack complete understanding of Earth's biological complexity. Agents designed to accelerate evolution might trigger runaway changes. Organisms intended to enhance human capabilities might prove incompatible with our existing biology. The road to extinction could be paved with good intentions, executed by intelligences too alien to predict the consequences of their actions. As Atlas continues its approach toward the inner solar system, these biological possibilities hover at the edge of scientific discourse, too speculative for formal papers, yet too plausible for complete dismissal. The object that initially appeared as an interesting astronomical curiosity might represent our first exposure to biological agents designed by intelligences we cannot comprehend, deployed through methods we cannot detect, for purposes we cannot imagine. And by the time we recognize the true nature of what we're facing, the intervention might already be complete, leaving us to wonder whether the changes we observe in ourselves and our world represent natural development or artificial influence we're powerless to resist. The question of biological cargo transforms Atlas from mere scientific anomaly into potential existential threat, one that challenges not just our survival, but our understanding of what it means to be human in a universe where life itself might be subject to manipulation by forces beyond our perception or control. Human beings possess an instinctive need to categorize and understand the phenomena we encounter. When faced with something genuinely anomalous, we tend to stretch existing explanations rather than accept that our categories might be inadequate. This psychological tendency has served us well throughout history, helping us make sense of a complex world through familiar patterns and analogies. But it also creates blind spots, areas where our very success at explanation prevents us from seeing possibilities that don't fit comfortable frameworks. Atlas challenges this tendency in profound ways. Every attempt to classify it as a natural object encounters obstacles, yet the alternative explanations seem to venture into realms of speculation that make scientists deeply uncomfortable. The result is a kind of cognitive dissonance, where the evidence points toward conclusions that our intellectual frameworks resist accepting. This resistance might itself be part of the phenomenon we're trying to understand. Consider the psychological impact of discovering that we're not alone in the universe, that intelligence exists on scales and timelines that dwarf our own experience. Such knowledge would fundamentally alter humanity's relationship to existence itself, stripping away the comfortable illusion of cosmic significance that has sustained us throughout our development. The possibility that Atlas represents such a revelation might explain why alternative explanations, however strained, continue to dominate scientific discourse. The timing of these realizations adds another dimension to their psychological weight. Humanity currently finds itself at a precarious juncture, facing climate change, resource depletion, and social fragmentation on a global scale. The discovery that we exist under the observation of vastly superior intelligences could either provide hope for guidance and assistance, or compound our sense of helplessness and irrelevance. The psychological preparation for such knowledge becomes as important as the knowledge itself. Yet preparation may be impossible when the very nature of the revelation remains uncertain. Atlas might represent benevolent observation, malevolent surveillance, or something entirely beyond our moral categories. The ambiguity forces us to consider multiple contradictory possibilities simultaneously, each carrying different implications for how we should understand ourselves and our future. This uncertainty creates psychological stress that no amount of scientific analysis can fully resolve. The silence surrounding Atlas amplifies these psychological challenges. If the object were clearly artificial and attempting communication, we would at least have a framework for response, however inadequate. Instead, we face the possibility of intelligence that observes without revealing itself, that judges without explaining its criteria, that acts without announcing its intentions. This asymmetry of knowledge creates a fundamental imbalance that human psychology struggles to process. The speed at which Atlas moves through our solar system adds urgency to these psychological pressures. We have only a limited window to gather information before the object disappears forever into interstellar space. This creates a sense of deadline pressure that intensifies every decision about how to respond. Should we attempt more aggressive observation? Should we try to send signals? Should we prepare for the possibility that more such visitors will follow? Each choice carries consequences we cannot fully predict, yet the approaching departure of Atlas forces decisions before we're ready to make them. The international nature of astronomy adds another layer of complexity to humanity's psychological response. Different cultures bring different frameworks for understanding anomalous phenomena, different levels of comfort with uncertainty, different assumptions about the nature of intelligence and communication. What seems obviously significant to one group might appear trivial to another. What triggers curiosity in some might provoke fear in others. The lack of unified human response to Atlas reflects these deeper divisions in how we process information that challenges our fundamental assumptions. Perhaps most psychologically challenging is the possibility that Atlas represents not a single anomalous event, but part of a larger pattern we're only beginning to perceive. If similar objects have been passing through our solar system undetected for centuries or millennia, then our entire understanding of humanity's cosmic context might be fundamentally flawed. We might not be isolated pioneers reaching out into an empty galaxy, but observed specimens in a carefully monitored environment. Our every development catalogued by watchers whose purposes we cannot fathom. This possibility transforms the psychological landscape of human existence in ways that extend far beyond astronomy. If we are being watched, then our privacy, our autonomy, our sense of self-determination all become questionable. The decisions we make might not be entirely our own if they're being influenced by observers whose capabilities we cannot assess. Even our ability to recognize that influence becomes suspect when dealing with intelligences potentially millions of years more advanced than ourselves. The worst-case psychological scenarios don't require direct intervention or communication from Atlas or its hypothetical creators. Simply knowing that we might be observed, that our development might be guided or constrained by external forces, changes the nature of human consciousness and agency. We cannot unknow the possibility once it has been seriously considered. The psychological impact of potential surveillance becomes permanent regardless of whether that surveillance actually exists. Yet there's also a strange comfort in these possibilities, a relief from the cosmic loneliness that has characterized human existence since we first looked up at the stars and wondered if anyone else was looking back. If Atlas represents intelligence, then we are not alone, however isolated that intelligence might choose to remain. If it represents technology, then solutions to our problems might exist, however inaccessible they might be to us currently. If it represents observation, then perhaps someone cares enough about our development to monitor our progress, however mysterious their motivations might remain. The psychological challenge of Atlas lies not just in what it might represent, but in the permanent uncertainty it introduces into human consciousness. We cannot return to the comfortable assumptions that preceded its detection. We cannot unsee the anomalies that make natural explanations feel inadequate. We cannot unfeel the unease that accompanies the possibility of being watched by intelligences we cannot comprehend. The object might depart our solar system, but the questions it raises will remain with us indefinitely, shaping how we understand ourselves and our place in a universe that might be far stranger and more populated than we ever imagined. As Atlas continues its swift passage through our cosmic neighborhood, these psychological dimensions of the encounter become as significant as the scientific ones. The object challenges not just our models of cometary behavior and interstellar chemistry, but our fundamental assumptions about consciousness, agency, and meaning in a universe where intelligence might operate on scales that render human experience essentially invisible. Whether Atlas represents natural phenomenon or artificial construct, its presence forces us to confront psychological realities we're not equipped to process, leaving us permanently changed by an encounter whose true nature we might never understand. The departure of Atlas will mark not an end, but a beginning, the start of a new phase of human consciousness where the possibility of observation by superior intelligences becomes a permanent feature of our psychological landscape. We will watch the skies differently, interpret anomalies differently, understand our own development differently, all because a strange object passed through our solar system and refused to fit comfortably into the categories we use to make sense of our world. That refusal to fit, that persistent ambiguity, might itself be the most significant communication we receive. A reminder that the universe contains mysteries we're not ready to solve and intelligences we're not prepared to recognize. The chemical fingerprint of Atlas continues to puzzle researchers in ways that extend far beyond simple curiosity. When we examine the spectral data more closely, we discover patterns that challenge our fundamental understanding of how matter behaves in the deep cold of interstellar space. The dominance of carbon dioxide over water represents more than just an unusual formation environment. It suggests processes that shouldn't be possible under the conditions we believe existed in the early galaxy. Think about it this way, as you let your mind drift along with these cosmic mysteries. Carbon dioxide requires specific temperature and pressure conditions to remain stable in solid form. In the harsh environment of interstellar space, bombarded by cosmic rays and stellar radiation for billions of years, these compounds should have been altered, broken down, or sublimated away long ago. Yet here they are, preserved in quantities that defy our models of chemical survival. The implications grow more unsettling when we consider what this preservation might represent. If Atlas formed naturally, then our understanding of interstellar chemistry needs fundamental revision. Materials we thought fragile prove remarkably durable. Processes we considered impossible apparently occur regularly. The very foundations of planetary science, built on observations of objects within our own solar system, might represent only a tiny fraction of the chemical possibilities that exist throughout the galaxy. But there's another interpretation that whispers at the edges of scientific discourse, one that most researchers hesitate to voice openly. What if the chemical composition of Atlas isn't the result of natural formation processes, but of deliberate design? What if the ratios of various compounds were chosen specifically to create a believable signature that would satisfy our instruments while concealing something else entirely? This possibility transforms the spectroscopic data from evidence of exotic chemistry into evidence of sophisticated engineering. The carbon dioxide that dominates Atlas's emissions could serve as an ideal dispersal medium, carrying microscopic payloads too small for our telescopes to detect. The unusual chemical ratios might represent not formation anomalies, but functional requirements for systems we cannot imagine. Consider how such a strategy might work. Any civilization capable of interstellar travel would understand that direct approach to younger species carries risks. Panic, defensive responses, unpredictable reactions, all could disrupt careful observation or intervention plans. But a probe disguised as natural debris would attract scientific attention without triggering immediate alarm. The chemical anomalies would ensure detailed study while remaining plausibly natural, creating the perfect balance of visibility and concealment. The outgassing patterns we observe from Atlas support this interpretation in troubling ways. Natural comets typically show chaotic, irregular activity as solar heating penetrates their surfaces unpredictably. Different regions warm at different rates, creating jets and plumes that vary dramatically over time. Yet Atlas maintains remarkably consistent output, as if its emissions were controlled rather than random. This consistency could indicate internal structure that regulates sublimation, perhaps layers of different materials that create steady release rates. But it could equally suggest active management, systems that monitor conditions and adjust output to maintain desired appearances. The very steadiness that makes Atlas easier to study might be evidence that something within is managing that steadiness deliberately. The radio silence that characterizes Atlas takes on new meaning when viewed through this lens. We've scanned across every frequency our instruments can monitor, listening for any hint of artificial signals. The absolute quiet we detect could mean the object is truly natural, lacking any technological components that might betray artificial origin. Or it could mean exactly the opposite, that any technology present is sophisticated enough to avoid detection by our primitive monitoring systems. Advanced civilizations would understand that electromagnetic emissions travel at light speed and can be detected across vast distances. Any probe operating in stealth mode would maintain complete radio silence, communicating only when necessary and perhaps through methods we cannot intercept. The absence of signals becomes not evidence of natural origin, but proof of competent design. This possibility introduces a disturbing asymmetry into our relationship with Atlas. If it truly is observing us, then our every action in studying it becomes part of the data it collects. The telescopes we point in its direction reveal our technological capabilities. The frequencies we scan show our communication methods. The papers we publish demonstrate our scientific processes and level of international cooperation. We cannot observe without revealing ourselves to whatever might be observing us in return. The trajectory of Atlas adds another layer to these concerns. Its hyperbolic path carries it through our solar system at precisely the right distance and speed to maximize observation opportunities while ensuring escape. Too close, and it risks detection as artificial. Too distant, and it cannot gather detailed information. Too slow, and it might be intercepted. Too fast, and observation time becomes insufficient. The orbital mechanics seem almost perfectly calibrated for reconnaissance purposes. From our perspective, this trajectory appears natural, the inevitable result of gravitational forces acting on an object with specific velocity and direction. But appearances can deceive, especially when dealing with technology advanced enough to manipulate those very forces. Small adjustments, disguised as natural outgassing effects, could fine-tune an approach that began as random and transform it into precisely what an observer would require. The thick disk origin of Atlas becomes particularly significant in this context. That ancient stellar population represents the oldest organized structures in our galaxy, regions where intelligence might have had billions of years to develop and mature. If Atlas truly comes from that environment, then it carries not just exotic chemistry, but potentially the legacy of civilizations that were already ancient when our solar system was still forming. The timescales involved stretch human imagination beyond comfortable limits. We think in terms of decades or centuries. Our longest-term projects rarely extend beyond generations. Yet if Atlas represents technology from the thick disk, then it embodies planning that spans geological ages, patience that endures across cosmic epochs, purposes that transcend individual lifetimes or even individual species. What motivates intelligence to operate on such scales? What goals require billions of years to achieve? What kind of consciousness can maintain focus across time spans that dwarf the entire history of complex life on Earth? These questions lead us into philosophical territory that science alone cannot navigate, realms where the nature of intelligence itself becomes the central mystery. The possibility that we're being observed by such ancient consciousness raises profound questions about agency and development. If civilizations that old exist, they would have witnessed the rise and fall of countless younger species. They would have seen patterns in development that we cannot perceive, cycles of growth and collapse that repeat across galactic history. From their perspective, humanity might represent not a unique phenomenon, but a familiar stage in a process they've observed thousands of times before. This realization could explain the apparent indifference of Atlas to our attempts at study. If it represents intelligence that has seen our story play out countless times with countless other species, then our particular development might hold little novelty or interest. We could be just another entry in a database that already contains millions of similar cases, noteworthy only for the specific details of our local implementation of universal patterns. The worst-case scenarios don't require malevolent intent from such observers. Even benevolent surveillance could undermine human autonomy if it operated according to principles we cannot understand. Interventions designed to help us might actually hinder our natural development. Guidance intended to prevent catastrophe might inadvertently cause the very problems it seeks to avoid. Good intentions become meaningless when filtered through intelligence so advanced that its actions appear random or even hostile to those they're meant to benefit. As Atlas continues its passage through our solar system, approaching the point where solar heating will intensify its outgassing and potentially reveal more about its true nature, we're forced to confront these possibilities without the comfort of definitive answers. The object might be nothing more than exotic ice and rock, a natural curiosity that challenges our models without challenging our fundamental assumptions about our place in the universe. But it might also represent our first confirmed encounter with intelligence that operates on scales we cannot comprehend, using methods we cannot detect for purposes we cannot imagine. If that's the case, then the questions raised by Atlas extend far beyond astronomy into realms of philosophy, psychology, and existential uncertainty that will reshape human consciousness long after the object itself has faded beyond the reach of our telescopes. The ambiguity itself might be intentional, a form of communication that respects our current limitations while preparing us for eventual revelations we're not yet ready to receive. The uncertainty that surrounds Atlas could be designed to provoke exactly the kind of questioning and speculation that accompanies genuine growth in understanding. We're being challenged to expand our categories, to question our assumptions, to consider possibilities that stretch our intellectual frameworks in directions they've never had to accommodate. Whether Atlas represents natural phenomenon or artificial construct, whether its presence is cosmic coincidence or calculated timing, whether its silence indicates absence or sophisticated concealment of intelligence, the object forces us to confront the limitations of human knowledge and the possibility that we exist in a universe far stranger and more populated than our current theories suggest. Tonight, as you drift towards sleep with these cosmic mysteries swirling through your thoughts, consider that the strange visitor we've been studying might be studying us in return, that the questions we ask about its nature might be less important than the conclusions it draws about ours, that our first encounter with extraterrestrial intelligence might not arrive as dramatic revelation, but as subtle observation that leaves us wondering long after the observers themselves have departed. The passage of Atlas through our solar system might mark not an end, but a beginning, the first of many such encounters that will gradually reshape human consciousness and our understanding of our place in a universe where intelligence might be far more common, far more ancient, and far more patient than we ever dared imagine. The worst-case scenarios we've explored tonight might not be possibilities to fear, but realities to accept as we take our first tentative steps into a larger cosmic community that has been watching and waiting for us to develop the wisdom necessary to recognize that we were never truly alone. The possibility that Atlas carries within itself the capacity to alter Earth's environment introduces scenarios that shift from mere speculation into realms of genuine existential concern. As you settle deeper into the quiet of this evening, consider how vulnerable our planet truly is to influences we cannot detect or control. The thin envelope of atmosphere that protects us, the delicate balance of chemistry that sustains life, the intricate web of biological relationships that support our existence, all could be disrupted by agents so small they remain invisible to our most sophisticated instruments. Throughout Earth's history, the introduction of foreign biological material has repeatedly demonstrated the fragility of established ecosystems. Species carried accidentally from one continent to another have devastated native populations, altered landscapes, and changed the fundamental character of entire regions. These disruptions occurred through natural processes of migration and adaptation. Now imagine such changes introduced deliberately by intelligence that understands biological systems at levels we're only beginning to approach. The chemical composition of Atlas, dominated by carbon dioxide in ratios unlike anything in our solar system, provides an ideal medium for dispersing microscopic payloads across planetary distances. As the object approaches the sun and its outgassing intensifies, expanding clouds of gas and dust spread millions of kilometers through space. Earth's orbit carries us directly through this dispersed material, exposing our atmosphere to whatever invisible passengers might be riding along with the more obvious chemical signatures our telescopes detect. The timing of this exposure feels almost deliberately calculated. Atlas arrives precisely when humanity has developed global industrial civilization, when our electromagnetic emissions announce our presence to any observer capable of detecting them, when our population and technological development have reached levels that might trigger concern among older, more established intelligences throughout the galaxy. The coincidence stretches credibility beyond comfortable limits. If Atlas were designed to deliver biological agents to planetary environments, it would operate according to principles we can barely imagine. The journey from the thick disk of our galaxy to our solar system spans billions of years, requiring preservation methods that go far beyond simple freezing. Any biological material capable of surviving such a voyage would need to be engineered for resilience at the molecular level, designed to remain viable despite exposure to cosmic radiation, impacts from interstellar dust, and the gradual degradation that affects all matter over cosmic timescales. Such engineering would represent biotechnology so advanced that we might not recognize it as artificial even when examining it directly. The boundary between biology and technology blurs when intelligence operates at such sophisticated levels. What appears natural to our instruments might actually represent the culmination of millions of years of research and development, deployed through methods that make our most advanced genetic engineering look like primitive trial and error. The effects of such biological intervention might not become apparent immediately. Advanced civilizations would understand that subtle, long-term changes prove more stable than dramatic, immediate alterations. Agents designed to modify human biology or Earth's environment might remain dormant for generations, activating only when specific conditions are met or certain developmental thresholds are crossed. By the time we recognize the changes occurring within ourselves or our world, the intervention would be complete and irreversible. This possibility transforms our understanding of human development and terrestrial evolution. The sudden leaps in complexity that punctuate life's history on Earth, the emergence of consciousness and intelligence, the rapid technological development of recent centuries, all might represent not natural progression, but careful cultivation by influences we've never recognized. We could be living within an experiment whose parameters were established long before our species existed, guided along predetermined paths by biological agents introduced through visitors like Atlas. The radio silence that characterizes this interstellar wanderer becomes even more significant when viewed through the lens of biological warfare or intervention. Any civilization deploying such agents would ensure complete stealth, avoiding any emissions that might reveal artificial origin or hostile intent. The perfect biological weapon or evolutionary catalyst would appear entirely natural, indistinguishable from the cosmic debris that regularly enters planetary systems throughout the galaxy. Even more troubling is the realization that if Atlas represents biological intervention, we might welcome the changes it introduces. Advanced civilizations would understand that resistance emerges from recognition of external influence. Biological agents designed to enhance human capabilities, extend lifespans, or improve cognitive function might be embraced enthusiastically by populations unaware of their artificial origin. We could be enthusiastically participating in our own transformation, guided by influences we cannot detect toward destinations we haven't chosen. The international response to Atlas reveals humanity's fundamental lack of preparation for such scenarios. Different nations monitor the object according to their own priorities and capabilities. Scientific institutions share data according to established protocols designed for natural phenomena. No coordinated planetary defense system exists to address biological threats arriving from interstellar space. We cannot quarantine our world against microscopic invaders, cannot even detect biological agents designed to remain hidden among the cosmic debris that constantly enters our atmosphere. This vulnerability extends beyond immediate biological effects to questions of identity and authenticity. If Earth's biosphere has been shaped by external intervention, then what aspects of human nature represent genuine development versus imposed direction? Our curiosity, our aggression, our tendency to explore and expand, our capacity for both cooperation and conflict, all could have been encouraged or suppressed by biological agents working over evolutionary timescales. The possibility that we are not entirely self-determined undermines our most basic assumptions about consciousness and free will. The worst-case biological scenarios don't require malicious intent from Atlas's hypothetical creators. Even well-meaning intervention could produce catastrophic results if those intervening lack complete understanding of Earth's biological complexity or if their goals conflict with human values and aspirations. Agents designed to create galactic harmony might suppress the very traits that make us uniquely human. Modifications intended to prepare us for interstellar civilization might eliminate the diversity and unpredictability that drive innovation and adaptation. As Atlas continues its approach toward the inner solar system, these biological possibilities hover at the edges of scientific discourse, too speculative for formal research, yet too plausible for complete dismissal. The object that initially appeared as an interesting astronomical curiosity might represent our first exposure to biotechnology so advanced that we mistake it for natural chemistry, deployed by intelligences so sophisticated that their interventions appear as random cosmic events. The departure of Atlas will not resolve these concerns but amplify them. If the object carries biological cargo, that material has already been dispersed throughout the inner solar system, mixed with the solar wind and distributed according to gravitational dynamics we cannot control or predict. Earth will continue to encounter this material for years or decades to come, long after the source has faded beyond the reach of our telescopes. We will be left to monitor our world and ourselves for changes we cannot anticipate, caused by influences we cannot identify. The psychological impact of these possibilities extends far beyond immediate concerns about biological safety. The knowledge that our development might be subject to external manipulation, that our evolution might not be entirely natural, that our future might be shaped by agents we cannot recognize or resist, fundamentally alters the human relationship to existence itself. We cannot unknow these possibilities once they've been seriously considered. They become permanent features of human consciousness, shadows that darken every achievement and complicate every decision about our species' direction. Perhaps most disturbing is the realization that if biological intervention represents a common strategy among advanced civilizations, then Atlas might not be unique but typical. The galaxy could be filled with such agents, carried by objects indistinguishable from natural debris, gradually shaping the development of countless worlds according to plans we cannot comprehend. The apparent emptiness we observe when searching for signs of extraterrestrial life might mask a reality where intervention occurs constantly through methods too subtle for us to detect. Tonight, as this strange visitor continues its silent passage through our cosmic neighborhood, we're forced to confront the possibility that the boundary between self and other, between natural and artificial, between autonomous development and guided evolution, might be far more porous than we've ever imagined. The object we initially catalogued as an unusual but harmless comet might represent our first encounter with biotechnology so sophisticated that it operates invisibly within the very processes we consider most fundamentally natural and our own. Whether Atlas carries such agents or represents nothing more than exotic interstellar chemistry, its presence reminds us that we exist in a universe where intelligence might operate through methods we cannot detect, toward goals we cannot understand across timescales that render human experience essentially invisible. The questions it raises about biological intervention and evolutionary manipulation will persist long after the object itself has departed, becoming permanent features of human consciousness as we struggle to understand our place in a cosmos that might be far more structured and far less natural than we ever dared imagine. The concept of first contact has shaped human imagination for decades, painted in scenarios of dramatic revelation, cosmic communication, and obvious encounters that leave no doubt about their artificial nature. We envision massive spacecraft appearing in our skies, clearly technological signals arriving from distant stars, or unambiguous messages that announce the presence of extraterrestrial intelligence in terms we cannot mistake or dismiss. But what if first contact has already occurred, not through the spectacular revelations we expect, but through the quiet passage of objects we initially classify as natural phenomena? This possibility reframes Atlas not as a potential harbinger of contact, but as contact itself, already in progress, already gathering the data that will determine how that contact proceeds. If the object truly represents technology rather than natural debris, then our response to its presence becomes our first communication with extraterrestrial intelligence, whether we recognize it as such or not. Every telescope we point at Atlas, every spectrum we analyze, every paper we publish about its properties becomes part of a conversation we didn't know we were having. The implications of unconscious first contact stretch far beyond astronomy into realms of diplomacy, psychology, and strategic planning that humanity has barely begun to consider. If we are being observed and evaluated by intelligence we cannot recognize, then our behavior during this initial encounter could determine the nature of all future interactions. Are we demonstrating the kind of curiosity and scientific rigor that suggests promising potential? Are we revealing the kind of international cooperation that indicates stable civilization? Or are we displaying the kind of fragmentation and short-term thinking that might concern observers worried about galactic stability? The silence of Atlas becomes particularly significant in this context. Rather than indicating absence of intelligence, it might represent a deliberate policy of non-interference, a decision to observe without revealing the observation, to study without contaminating the natural development processes being studied. Advanced civilizations might have learned that direct contact with younger species creates more problems than benefits, disrupting natural development patterns and introducing variables that make meaningful assessment impossible. This interpretation suggests that the galaxy might operate according to protocols we don't understand, rules that govern how older civilizations interact with younger ones. The apparent absence of extraterrestrial signals that has puzzled researchers for decades might not indicate the absence of intelligence, but the success of non-interference policies designed to preserve the natural development of emerging species. We don't hear from advanced civilizations because they have chosen not to speak, not because they don't exist. If Atlas represents such a policy in action, then humanity finds itself in a peculiar position. We are advanced enough to detect the observer, but not advanced enough to recognize what we're seeing. We can measure its chemistry, track its motion, and analyze its properties, but we cannot definitively determine whether we're studying a comet or conducting our first diplomatic exchange with extraterrestrial intelligence. The ambiguity itself might be intentional, designed to test how we respond to uncertainty and how we handle possibilities that challenge our fundamental assumptions. The speed at which Atlas moves through our solar system adds urgency to this potential first contact scenario. If the object truly is observing us, then our window of opportunity to make a positive impression is limited by orbital mechanics beyond our control. The decisions we make during its passage, the quality of our scientific analysis, the level of international cooperation we demonstrate, all become part of a permanent record that will influence how we are perceived by intelligences whose capabilities and intentions remain entirely unknown. Even more unsettling is the possibility that this isn't our first such encounter, but simply the first one we've been advanced enough to detect. If probes like Atlas pass regularly through our solar system, disguised as natural phenomena, then humanity might have been under observation for far longer than we realize. Our development might already be well documented, our characteristics already catalogued, our potential already assessed according to criteria we cannot imagine. This scenario transforms the cosmic loneliness that has characterized human existence into something far more complex. We might not be alone, but we might also not be welcome to know that we're not alone. The intelligence that observes us might have concluded that direct contact would be premature, disruptive, or dangerous, either to us or to themselves. We could be living in a carefully maintained illusion of isolation, protected from knowledge we're not ready to handle by watchers whose discretion is so complete that we mistake their presence for absence. The psychological preparation required for such realities exceeds anything our species has previously confronted. The discovery that we exist under observation by vastly superior intelligences could either inspire us to greater achievements or paralyze us with feelings of inadequacy and helplessness. The knowledge that our development might be guided, monitored, or constrained by external forces could undermine the sense of agency and self-determination that drives human progress and innovation. Yet there might also be comfort in these possibilities. Relief from the cosmic loneliness that has haunted human consciousness since we first looked up at the stars and wondered if anyone else was looking back. If Atlas represents intelligence, then we are not alone in the universe, however carefully that companionship might be concealed. If it represents technology, then solutions to our problems might exist, however inaccessible they might currently be. If it represents observation, then perhaps someone cares enough about our development to monitor our progress, however mysterious their motivations might remain. The departure of Atlas will leave us with questions rather than answers, speculation rather than certainty, possibilities rather than proof. But it will also leave us permanently changed, forced to consider that first contact might not arrive as dramatic revelation but as subtle infiltration, not as obvious communication but as careful observation, not as the beginning of a relationship but as the continuation of surveillance that has been ongoing for far longer than we suspected. The worst-case scenarios surrounding first contact don't require invasion, destruction, or even direct interference. The worst case might simply be the realization that we are not the explorers we thought ourselves to be, but the explored, not the discoverers, but the discovered, not the initiators of contact, but the subjects of study by intelligences whose purposes and capabilities remain forever beyond our comprehension. The illusion of cosmic significance that has sustained human civilization might prove to be exactly that. An illusion, maintained by observers who understand that knowledge of observation would fundamentally alter the very phenomena they're trying to understand. Tonight, as Atlas continues its passage through our cosmic neighborhood, we're left to contemplate the possibility that first contact has already occurred, is occurring right now through methods so sophisticated that we participate in it without recognizing it. The object we study might be studying us in return, drawing conclusions about our nature, our potential, our readiness for whatever comes next in a universe where intelligence operates on scales and through methods that challenge every assumption we've made about communication, contact, and our place among the stars. The questions raised by Atlas will persist long after the object itself has faded from view, becoming permanent features of human consciousness as we struggle to understand whether we are alone in the universe or simply alone in our awareness of company that has been with us all along. As we drift deeper into the mysteries surrounding Atlas, there's another layer to this cosmic puzzle that deserves our gentle attention. The object's behavior as it approaches the sun reveals patterns that continue to challenge our understanding of what natural comets should do. While most icy bodies from the outer reaches of space begin their outgassing activities in predictable ways, responding to solar heating with chaotic bursts and irregular plumes, Atlas maintains a curious consistency that feels almost choreographed. Picture, if you will, the way a natural comet typically behaves as it draws closer to our star. Different regions of its surface warm at different rates, creating jets and geysers that vary wildly in intensity and direction. The rotation of the nucleus exposes various patches to sunlight, causing brightness to fluctuate as different areas become active or dormant. It's a messy, unpredictable process, driven by the physics of sublimation and the chaotic structure of primitive, icy materials. Yet Atlas presents us with something altogether more orderly. Its emissions remain remarkably stable, its brightness varies within that suggests either very unusual internal structure or something narrow parameters, and its spectral signatures show a consistency else entirely. For astronomers accustomed to the object is regulating its output erratic behavior of typical comets, this steadiness feels almost artificial, as if something within rather than simply responding to external heating. The implications pull outward into uncomfortable territory. If Atlas truly of such regulation, whether natural or artificial, possesses internal mechanisms that control its outgassing, then we're dealing with either geological processes we've never encountered before, or engineering principles we can barely imagine. Both possibilities challenge our fundamental understanding of how small icy bodies should behave in the harsh environment of space. Consider the precision required to maintain such consistent output across the vast temperature gradients that exist between interstellar space and the inner solar system. Natural processes tend toward chaos and variation, not the kind of careful modulation we observe from Atlas. Ice sublimes when heated, creating pressure that forces gas and dust to escape through the path of least resistance. This should produce irregular, unpredictable activity, not the steady, measured emissions we're documenting. The chemical composition adds another puzzle piece to this emerging picture. The dominance of carbon dioxide over water creates outgassing that begins at much greater distances from the sun than we typically observe. This early activity provides extended periods of concealment, shrouding the nucleus in expanding clouds of gas and dust long before detailed observations become possible. Whether by chance or design, this chemical signature provides perfect camouflage exactly when it would be most needed. The size estimates for Atlas's nucleus continued to confound researchers, trapped within uncertainty ranges that span orders of magnitude. This isn't merely a technical limitation of our instruments, but a fundamental consequence of the object's behavior. The steady outgassing creates a persistent veil that makes direct observation of the solid nucleus impossible. We can study the envelope, analyze the emissions, and track the overall motion, but the actual object responsible for these phenomena remains hidden behind its own activity. This concealment raises troubling questions about what we're actually observing. If Atlas were designed to avoid detailed scrutiny, it could hardly be more effective. The very phenomena we expect from natural comets, the formation of a coma through sublimation, becomes an impenetrable barrier to understanding. We're left to infer the properties of the source from the characteristics of its emissions, a process that allows for multiple interpretations of the same data. The trajectory of Atlas through our solar system continues to follow orbital mechanics with mathematical precision, yet the path itself raises questions about probability and coincidence. The object approaches close enough to Earth to allow detailed study, yet maintains sufficient distance to avoid any risk of collision or capture. It moves fast enough to ensure eventual escape, yet slowly enough to provide extended observation opportunities. The geometry feels almost optimized for reconnaissance purposes. From our perspective, trapped within the reference frame of our own solar system, this trajectory appears natural, the inevitable result of gravitational forces acting on an object with specific initial conditions. But appearances can deceive when dealing with technology advanced enough to manipulate those very forces. Small adjustments, disguised as natural outgassing effects, could fine-tune an approach that began as random chance and transform it into precisely what an observer would require. The radio silence that continues to characterize Atlas adds another layer of ambiguity to our observations. Our most sensitive receivers detect nothing but the natural emissions expected from sublimating volatiles and the cosmic background radiation that fills all of space. This quiet could indicate genuine absence of artificial systems, or it could demonstrate sophisticated engineering designed to operate without detectable signatures. Advanced civilizations would understand that electromagnetic emissions travel at light speed and can be intercepted across interstellar distances. Any technology designed for stealth operations would maintain absolute radio silence, perhaps communicating through methods we cannot monitor or detecting entirely through passive means. The absence of artificial signals becomes not evidence of natural origin, but potential proof of competent design. The psychological weight of these possibilities grows heavier as Atlas continues its passage through our cosmic neighborhood. Each day brings new observations that fit multiple interpretations, new data that supports both natural and artificial explanations with equal plausibility. The ambiguity itself becomes a kind of communication, forcing us to confront the limitations of our knowledge and the possibility that some mysteries are designed to remain unsolved. The international scientific community finds itself in an unprecedented position, studying an object that might be studying them in return. Every telescope pointed at Atlas, every spectrum analyzed, every conference presentation delivered, could be revealing information about human technological capabilities, scientific methods, and international cooperation to observers whose capabilities and intentions remain entirely unknown. This asymmetry of information creates a fundamental imbalance that extends far beyond astronomy into realms of strategy and diplomacy for which humanity has no established protocols. We cannot know what conclusions might be drawn from our behavior, what criteria might be used to evaluate our responses, what implications our actions might carry for future interactions with intelligences we cannot recognize or understand. The speed at which Atlas moves through our solar system adds urgency to these concerns. Our window of opportunity for detailed observation is limited by orbital mechanics beyond our control. Soon, this mysterious visitor will begin its long journey back into interstellar space, taking whatever secrets it might possess beyond the reach of our most powerful telescopes. We're racing against time to gather information about an object that might be gathering information about us. The possibility that Atlas represents technology rather than natural debris introduces scenarios that challenge every assumption we've made about first contact, alien intelligence, and humanity's place in the cosmic order. If we are being observed by intelligences we cannot detect, evaluated according to criteria we cannot understand, then our cosmic isolation might be an illusion maintained by watchers whose discretion is so complete that we mistake presence for absence. The thick disk origin of Atlas adds temporal dimensions to these mysteries that stretch human comprehension beyond comfortable limits. If the object truly comes from that ancient stellar population, then it carries within itself the legacy of epochs when our galaxy was young and chaotic, when conditions existed that we can barely model or imagine. The survival of any object across such vast spans of time challenges our understanding of durability, preservation, and the very nature of matter itself. Yet survival across billions of years might represent not extraordinary luck, but extraordinary engineering. Technology designed to operate across cosmic epochs would need to be self-maintaining, self-repairing, perhaps even self-modifying to adapt to changing conditions. The very characteristics that make Atlas's natural survival seem implausible might be evidence of artificial design optimized for exactly such longevity. The biological implications of Atlas's passage continue to hover at the edges of scientific discourse, too speculative for formal research, yet too significant for complete dismissal. If the object carries within its nucleus or its emissions any form of biological material, whether natural or engineered, then Earth's encounter with this interstellar visitor becomes potentially transformative in ways we cannot predict or control. The dispersal patterns created by outgassing spread material across millions of kilometers of space, creating expanding clouds that Earth's orbit carries us through whether we recognize the exposure or not. We cannot filter space, cannot quarantine our planet against microscopic invaders, cannot even detect biological agents designed to remain hidden among the cosmic debris that constantly enters our atmosphere. The timing of this potential exposure feels almost calculated, occurring precisely when humanity has developed global civilization, when our electromagnetic emissions announce our presence to any observer capable of detecting them, when our population and technology have reached levels that might trigger interest or concern among older, more established intelligences throughout the galaxy. The worst-case scenarios don't require malicious intent from Atlas or its hypothetical creators. Even benevolent observation could have consequences we cannot anticipate if it operates according to principles we don't understand. Interventions designed to help might actually hinder natural development. Guidance intended to prevent catastrophe might inadvertently cause the problems it seeks to avoid. The road to unintended consequences could be paved with good intentions filtered through intelligence so advanced that its actions appear random or even hostile to those they're meant to benefit. As you settle deeper into the quiet of this evening, consider that the questions raised by Atlas extend far beyond the object itself into fundamental uncertainties about the nature of intelligence, the structure of the galaxy, and humanity's role in cosmic processes that might have been unfolding for billions of years before our sun was born. Whether Atlas represents natural phenomenon or artificial construct, whether its presence is cosmic coincidence or calculated timing, whether its silence indicates absence or sophisticated concealment of intelligence, the object forces us to confront possibilities that challenge every comfortable assumption we've made about our place among the stars. The departure of Atlas will not resolve these mysteries but deepen them, leaving us with permanent questions about observation and autonomy, about natural development and external influence, about the very nature of contact in a universe where intelligence might operate through methods so subtle that we participate in encounters without recognizing them as such. Tonight, as this strange visitor continues its swift passage through our cosmic neighborhood, we're reminded that the universe might be far more populated, far more structured, and far more carefully monitored than we've ever dared imagine. The object we initially catalogued as an unusual but ultimately harmless comet might represent our first confirmed glimpse of intelligence that operates on scales we cannot comprehend, using methods we cannot detect, for purposes that remain forever beyond our understanding. Whether Atlas carries within itself the seeds of transformation or represents nothing more than exotic chemistry from ancient stellar environments, its presence has already changed us, forcing humanity to confront the possibility that we exist not in cosmic isolation, but under the patient observation of watchers whose purposes and capabilities we may never fully understand. The possibility that Atlas represents something more than natural debris forces us to confront scenarios that challenge our most fundamental assumptions about survival and existence in a universe we're only beginning to understand. As you let your thoughts drift with these cosmic mysteries, consider what it might mean if this strange visitor embodies not just observation or communication, but something far more direct and immediate in its implications for humanity's future. Throughout our planet's long history, mass extinctions have punctuated the fossil record with startling regularity. The Great Dying that ended the Permian period, the asteroid impact that eliminated the dinosaurs, the mysterious events that cleared the stage for new forms of life to emerge and flourish. Scientists have traditionally explained these catastrophes through natural processes, asteroid impacts, volcanic eruptions, climate shifts that overwhelmed existing ecosystems and created opportunities for evolutionary innovation. Yet the timing and thoroughness of these extinctions sometimes feel almost too convenient, too perfectly calibrated to clear away established life forms and make room for new experiments in biological complexity. What if some of these pivotal moments in Earth's history weren't entirely natural? What if they represented interventions, carefully timed adjustments to our planet's biological trajectory, carried out by intelligences whose patience spans geological epochs? If Atlas truly represents technology from the ancient thick disk of our galaxy, then it carries within itself the legacy of civilizations that were already mature when our solar system was still forming from cosmic dust. Such beings would have witnessed the rise and fall of countless species across billions of years, developing perspectives on biological development that transcend individual worlds or even individual stellar neighborhoods. They might view extinction not as tragedy, but as necessary pruning that keeps galactic ecosystems healthy and diverse. The chemical composition of Atlas takes on darker significance when viewed through this lens. The unusual dominance of carbon dioxide over water could represent more than exotic formation conditions or sophisticated camouflage. It could indicate a delivery system optimized for dispersing agents that work slowly, subtly, over timescales that make detection impossible until effects become irreversible. The outgassing we interpret as natural sublimation might actually be controlled release of compounds designed to alter atmospheric chemistry, disrupt biological processes, or trigger changes that won't become apparent for generations. The consistency of Atlas's emissions, so unlike the chaotic activity typical of natural comets, supports this interpretation in troubling ways. Natural processes tend toward randomness and variation, but engineered systems maintain steady, predictable output. If the object were designed to deliver specific dosages of transformative agents across precise timeframes, it would need exactly the kind of regulated emission patterns we observe. Even more unsettling is the possibility that such interventions have occurred before, multiple times throughout Earth's history, each event carefully timed to guide evolutionary development along desired pathways. The sudden appearance of complex multicellular life, the rapid diversification that followed major extinctions, the mysterious emergence of consciousness and intelligence, all could represent not random chance, but deliberate cultivation by influences we've never recognized as artificial. The thick disk origin of Atlas adds temporal dimensions to these concerns that stretch beyond human comprehension. If the object represents technology from that ancient stellar population, then it embodies planning that spans cosmic ages, patience that endures across epochs when entire galaxies collide and merge. What motivates intelligence to operate on such vast timescales? What goals require billions of years to achieve? What kind of consciousness can maintain focus across periods that dwarf the entire history of complex life on Earth? The answers might lie in concepts of cosmic gardening, galactic management on scales that make planetary ecology seem trivial by comparison. If advanced civilizations view the galaxy as a single integrated system, they might periodically adjust the biological trajectory of individual worlds to maintain overall balance and diversity. Earth's biosphere could represent just one experiment among millions, subject to periodic modification to prevent stagnation or to test new evolutionary possibilities. Such interventions wouldn't necessarily be malevolent. They might represent careful stewardship, designed to maximize the potential for interesting and diverse forms of life to emerge throughout the galaxy. But from our perspective, trapped within a single planetary biosphere, any external manipulation of our evolutionary trajectory would represent an existential threat of the highest magnitude. We cannot consent to changes we don't recognize, cannot resist influences we cannot detect, cannot even understand the criteria by which our world might be judged suitable for modification. The radio silence that characterizes Atlas becomes even more significant in this context. Any civilization deploying such interventions would maintain absolute stealth, avoiding any emissions that might reveal artificial origin or hostile intent. The most effective biological modification would appear entirely natural, indistinguishable from the environmental changes that regularly challenge planetary ecosystems throughout the galaxy. The trajectory of Atlas through our solar system provides optimal positioning for such deployment. The object passes close enough to Earth to expose our atmosphere to its emissions, yet maintains sufficient distance to avoid suspicion of deliberate targeting. The hyperbolic escape path ensures that by the time any effects become apparent, the source has long since disappeared into interstellar space beyond the reach of investigation or retaliation. The size uncertainty surrounding Atlas's nucleus adds another layer of concern to these scenarios. If the object were designed to carry biological agents across interstellar distances, it would need to be large enough to preserve those agents against cosmic radiation and impacts, yet small enough to avoid attracting excessive attention. The current range of estimates places it squarely within parameters that would satisfy both requirements, neither too small to maintain biological integrity nor too large to appear suspiciously artificial. Perhaps most disturbing is the realization that if Atlas represents such intervention, we might welcome the changes it introduces. Advanced civilizations would understand that resistance emerges from recognition of external influence. Biological modifications designed to enhance human capabilities, extend lifespans, or improve cognitive function might be embraced enthusiastically by populations unaware of their artificial origin. We could find ourselves eager participants in our own transformation, guided toward destinations we haven't chosen by influences we cannot recognize. The international response to Atlas reveals humanity's complete lack of preparation for such scenarios. No coordinated planetary defense system exists to address biological threats arriving from interstellar space. Different nations monitor the object according to their own priorities and capabilities, sharing data through scientific channels designed for natural phenomena rather than potential biological warfare. We cannot quarantine Earth against microscopic invaders, cannot even detect agents designed to remain hidden among the cosmic debris that constantly enters our atmosphere. This vulnerability extends beyond immediate biological effects to questions of identity and authenticity that strike at the heart of human consciousness. If our evolutionary trajectory has been subject to external manipulation, then what aspects of human nature represent genuine development versus imposed direction? Our curiosity, our aggression, our capacity for both cooperation and conflict, our drive to explore and expand beyond our home world, all could have been encouraged or suppressed by biological agents working over evolutionary timescales. The possibility that we are not entirely self-determined undermines the foundation of human agency and free will. If our thoughts and behaviors result from modifications introduced by ancient visitors, then the very concepts of choice and responsibility become questionable. We might be living according to programs written by intelligences whose goals and methods we cannot comprehend, following scripts we've never been allowed to read. The worst-case scenarios don't require immediate catastrophic effects. The most effective interventions would work gradually, subtly across generations, introducing changes that feel natural and inevitable to those experiencing them. Population decline disguised as social choice, cognitive modifications presented as educational advancement, biological alterations framed as medical breakthroughs, all could represent external influences operating through mechanisms we mistake for internal development. The timing of Atlas's arrival adds urgency to these concerns. If the object carries agents designed to modify human development, its passage through our solar system occurs precisely when our species has reached levels of population, technology, and environmental impact that might trigger intervention by observers concerned about galactic stability. Our radio emissions announce our presence across interstellar distances. Our industrial activity alters atmospheric composition in ways detectable from space. Our nuclear capabilities suggest potential for disrupting not just our own world, but possibly others. From the perspective of ancient civilizations that have witnessed countless species follow similar developmental trajectories, humanity might appear as a predictable case study approaching critical thresholds that require management. The intervention represented by Atlas could be routine maintenance, a standard response to species that grow too quickly or develop too aggressively for galactic comfort. As Atlas continues its passage through our solar system, approaching the point where solar heating will intensify its outgassing and potentially release whatever biological cargo it might carry, we're forced to confront these possibilities without the comfort of definitive answers or effective countermeasures. The object that initially appeared as an interesting but harmless astronomical curiosity might represent our first encounter with biological modification technology so sophisticated that we mistake its deployment for natural environmental change. The departure of Atlas will not eliminate these concerns but amplify them. If the object carries biological agents, that material will continue to circulate through the solar system long after its source has faded beyond the reach of our telescopes, mixed with solar wind and distributed according to gravitational dynamics we cannot control or predict. Earth will encounter this material repeatedly over years or decades, each exposure potentially introducing or reinforcing changes we cannot recognize until they become irreversible. The psychological impact of these possibilities extends far beyond immediate concerns about biological safety into realms of existential uncertainty that challenge the very foundations of human identity. The knowledge that our development might be subject to external manipulation, that our evolution might not be entirely natural, that our future might be shaped by agents we cannot identify or resist, fundamentally alters our relationship to existence itself. We cannot unknow these possibilities once they've been seriously considered. They become permanent features of human consciousness, shadows that darken every achievement and complicate every decision about our species' direction. The illusion of autonomy that has sustained human civilization might prove to be exactly that, an illusion maintained by influences so subtle that we participate in our own modification without recognizing the process until it reaches completion. Tonight, as this mysterious visitor continues its swift passage through our cosmic neighborhood, we're left to contemplate the possibility that the worst-case scenario isn't dramatic destruction or obvious invasion, but gradual transformation that feels natural, even as it rewrites the fundamental nature of human existence. The object we study might be implementing changes that will become apparent only when viewed across the timescales on which its creators operate, modifications that will seem like natural evolution until future generations discover evidence of external influence in their own biology. Whether Atlas represents such intervention or merely exotic interstellar chemistry, its presence reminds us that we exist in a universe where intelligence might operate through methods so sophisticated that victims welcome their own transformation, where survival might depend not on avoiding contact with superior beings, but on recognizing when that contact is already occurring through channels we never thought to monitor. The questions raised by Atlas will persist long after the object itself has disappeared into interstellar space, becoming permanent features of human consciousness as we struggle to understand whether the changes we observe in ourselves and our world represent natural development or artificial influence we lack the wisdom to recognize or the power to resist. As we drift deeper into the cosmic enigma that is Atlas, there's a haunting realization that begins to crystallize in the quiet corners of astronomical discourse. The object's journey through our solar system isn't just a passage, it's potentially a reconnaissance mission whose scope and sophistication we're only beginning to glimpse. Each measurement we take, each spectrum we analyze, each paper we publish about its properties becomes part of a vast data collection effort that might extend far beyond our understanding. Consider the precision with which Atlas approaches our neighborhood. Its trajectory brings it close enough to sample our electromagnetic environment to measure the radio leakage that has been bleeding into space since we first began broadcasting. From its vantage point, traveling at tremendous speed yet maintaining optimal observation distance, it could be cataloging everything about human civilization that reveals itself through our technological signatures. The timing feels almost surgical in its precision. Atlas arrives just as humanity has reached a critical threshold in our development as a spacefaring species. We've learned to detect interstellar visitors. We've begun serious discussions about messaging extraterrestrial intelligence, and our industrial footprint has grown large enough to alter our planet's atmospheric composition in ways detectable from space. If there were ever a moment when a young civilization might attract the attention of galactic observers, this would be it. The silence that surrounds Atlas becomes even more meaningful when viewed as a deliberate strategy rather than natural absence. Advanced civilizations would understand that the most effective surveillance operates invisibly, gathering information without alerting the subjects to their presence. The complete lack of artificial signals doesn't prove the object is natural. It might actually demonstrate the opposite, showing technology so sophisticated that it leaves no traces we can recognize. This possibility transforms our entire understanding of cosmic surveillance. Rather than expecting obvious signs of alien presence, we might need to look for the absence of such signs, for objects that behave too naturally, that fit too perfectly into our expectations while carrying subtle anomalies that suggest something more complex beneath the surface. Atlas exemplifies this pattern, natural enough to avoid immediate suspicion, yet strange enough to demand detailed study. The chemical fingerprint of Atlas continues to puzzle researchers in ways that extend beyond simple scientific curiosity. The ratios of compounds don't match anything in our solar system, suggesting formation in environments so different from our own that they challenge our fundamental understanding of how planetary systems develop. Yet these same unusual ratios provide perfect camouflage for an artificial object, creating spectral signatures that appear exotic but remain plausibly natural. The outgassing patterns we observe might serve multiple functions simultaneously. To us, they look like natural sublimation as solar heating releases volatile compounds from the nucleus. But to a sophisticated probe, The same emissions could power instruments, adjust trajectory, or maintain communication with distant controllers through methods we cannot detect. The coma that conceals the nucleus from detailed observation might hide not just irregular ice and rock, but technology so advanced we wouldn't recognize it as artificial even if we could see it clearly. The thick disk origin of Atlas adds layers of complexity that stretch human imagination beyond comfortable limits. If the object truly comes from that ancient stellar population, then it represents not just technology but archaeology, carrying within itself the legacy of civilizations that flourished when our galaxy was young and violent. The engineering required to preserve functionality across such vast timescales suggests capabilities that transcend anything we can currently conceive. Such ancient technology might operate according to principles entirely foreign to our understanding, systems that repair themselves, adapt to changing conditions, perhaps even evolve over billions of years of operation. The very characteristics that make Atlas's survival seem improbable for a natural object might be evidence of design optimized for exactly such longevity, built by intelligences that think in terms of galactic rotations rather than human lifespans. The implications cascade outward into scenarios that challenge every assumption we've made about intelligence, communication, and contact between civilizations. If Atlas represents technology from the thick disk, then we might be witnessing the product of beings so ancient that they predate not just human civilization, but complex life on Earth itself. Their perspective on our development would be informed by billions of years of observation, by patterns of rise and fall repeated countless times across the galaxy. From such a vantage point, humanity might appear not as a unique phenomenon worthy of special attention, but as a predictable stage in processes they've witnessed thousands of times before. Our technological development, our social challenges, our environmental crises, all could represent familiar patterns that play out with minor variations wherever intelligence emerges from planetary evolution. We might be just another data point in a survey so vast and comprehensive that individual civilizations become statistical samples rather than unique cases. This realization carries profound implications for how we understand our cosmic significance. The loneliness that has characterized human existence since we first looked up at the stars and wondered if anyone else was looking back might be an illusion, maintained by observers whose methods are so sophisticated that we mistake presence for absence, surveillance for solitude. We might never have been alone, only alone in our awareness of companionship that operates on scales we cannot perceive. The biological implications of Atlas's passage continue to hover at the edges of legitimate scientific concern. If the object carries within its emissions any form of biological material, whether natural spores preserved from ancient stellar environments or engineered organisms designed for specific purposes, then Earth's encounter with this interstellar visitor becomes potentially transformative in ways we cannot predict or control. The dispersal mechanisms created by outgassing operate on scales that dwarf human ability to monitor or contain. Expanding clouds of gas and dust spread across millions of kilometers, carrying microscopic passengers into regions where Earth's orbit will inevitably encounter them. We cannot filter space, cannot screen our atmosphere against invisible invaders, cannot even detect biological agents designed to remain hidden among the cosmic debris that constantly rains down upon our planet. The timing of this potential exposure feels calculated rather than coincidental. Atlas arrives precisely when human civilization has reached levels of complexity and planetary impact that might trigger intervention by observers concerned about galactic stability. Our electromagnetic emissions announce our presence across interstellar distances. Our industrial activity alters atmospheric composition in ways detectable from space. Our population growth and resource consumption follow trajectories that might alarm intelligences with longer perspectives on sustainability. If Atlas represents biological intervention, it operates according to principles that transcend our current understanding of genetics, evolution, and planetary ecology. The agents it might deploy could work subtly across generations, introducing modifications that feel natural to those experiencing them while guiding development along predetermined pathways. We might welcome changes that enhance our capabilities while remaining unaware of their artificial origin, enthusiastic participants in our own transformation. The psychological dimensions of these possibilities extend far beyond immediate concerns about biological safety or technological surveillance. The knowledge that our development might be subject to external observation or intervention fundamentally alters the human relationship to agency, choice, and self-determination. We cannot unknow the possibility once it has been seriously considered, cannot return to comfortable assumptions about cosmic isolation once the evidence suggests otherwise. The departure of Atlas will not resolve these uncertainties but deepen them, leaving humanity with permanent questions about observation and autonomy, about natural development and external influence, about the very nature of contact in a universe where intelligence might operate through methods so subtle that we participate in encounters without recognizing them as such. The object that initially appeared as an unusual but ultimately harmless comet might represent our first confirmed glimpse of technology so advanced that we mistake it for natural phenomenon. Whether Atlas carries within itself the instruments of surveillance, the agents of transformation, or simply the exotic chemistry of ancient stellar environments, its presence has already changed us, forcing humanity to confront possibilities that challenge every comfortable assumption we've made about our place among the stars. The questions it raises about cosmic loneliness, external observation, and the nature of intelligence itself will persist long after the object has faded beyond the reach of our telescopes. As this strange visitor continues its swift passage through our cosmic neighborhood, we're reminded that the universe might be far more structured, far more carefully monitored, and far less natural than we've ever dared imagine. The worst-case scenarios we've explored tonight might not be theoretical possibilities, but glimpses of realities we're only beginning to perceive. Fragments of a cosmic order where young civilizations like ours exist under the patient observation of watchers whose purposes and capabilities remain forever beyond our understanding. The silence that surrounds Atlas might not indicate absence of intelligence, but presence of intelligence so sophisticated that it observes without being observed, influences without being recognized, guides without being detected. In such a universe, the cosmic loneliness that has defined human consciousness might prove to be our greatest illusion, maintained by observers who understand that some truths are too transformative to reveal until civilizations demonstrate readiness to handle knowledge that fundamentally alters their relationship to existence itself. Tonight, as you drift towards sleep with these cosmic mysteries swirling through your thoughts, consider that the questions raised by Atlas extend far beyond astronomy into realms of philosophy, psychology, and existential uncertainty that will reshape human consciousness long after the object itself has departed. Whether it represents natural phenomenon or artificial construct, cosmic coincidence or calculated timing, absent intelligence or sophisticated concealment, Atlas forces us to confront the possibility that we exist in a universe far stranger and more populated than our current theories suggest, where watchers disguised as wanderers might be the rule rather than the exception, and where the worst-case scenario isn't invasion or destruction, but the gradual realization that we were never truly alone, only alone in our understanding of the company we've been keeping all along. The mathematical precision of Atlas's orbit tells its own unsettling story, one written in the language of gravitational mechanics and celestial choreography. As you let these cosmic mysteries carry you gently towards sleep, consider how the object's path through our solar system follows trajectories that seem almost too perfect for coincidence, too carefully calibrated for random chance. When astronomers first calculated the orbital elements of this interstellar wanderer, they discovered something that should have been remarkable yet felt oddly familiar. The hyperbolic escape velocity, the angle of approach, the timing of perihelion passage, all combined to create what mission planners would recognize as an optimal reconnaissance trajectory, close enough for detailed observation, distant enough to avoid capture, fast enough to ensure escape regardless of any response we might attempt. The precision extends beyond mere orbital mechanics into realms of strategic planning that suggest either extraordinary coincidence or extraordinary foresight. Atlas approaches our solar system from a direction that maximizes its exposure to Earth's electromagnetic emissions while minimizing interference from solar radiation and magnetic field fluctuations. Its path carries it through regions where radio signals from our planet propagate with minimal distortion, where atmospheric spectroscopy becomes possible across multiple wavelengths, where the subtle signatures of industrial civilization can be detected and analyzed. Even the timing of its closest approach seems calibrated for optimal data collection. Atlas reaches perihelion during a period when Earth's orbital position provides extended observation opportunities, when our planet's day-night cycle exposes different hemispheres to scrutiny, when seasonal variations in atmospheric composition create maximum information content for any observer capable of detecting such subtleties. The synchronization feels less like chance and more like scheduling. The radio silence that continues to characterize Atlas becomes even more significant when viewed against this backdrop of apparent precision. Our most sensitive receivers scan across frequencies that span the electromagnetic spectrum, listening for any hint of artificial signals or structured communications. The absolute quiet we detect could indicate natural origin, but it might equally suggest technology sophisticated enough to operate without detectable emissions, advanced enough to gather information through purely passive means. This possibility introduces a disturbing asymmetry into our relationship with the object. If Atlas truly represents intelligence, then every action we take in studying it becomes part of the intelligence it gathers about us. The telescopes we point in its direction reveal our optical capabilities. The frequencies we monitor expose our communication technologies. The international coordination we display demonstrates our level of species cooperation. We cannot observe without being observed in return. The chemical composition of Atlas continues to resist comfortable categorization, displaying ratios of compounds that suggest formation in environments unlike anything in our local stellar neighborhood. The unusual dominance of carbon dioxide over water creates outgassing patterns that begin at greater distances from the sun than typical comets, providing extended periods of concealment exactly when such concealment would prove most valuable for reconnaissance purposes. Yet beneath these chemical anomalies lies something even more puzzling. The consistency of emissions, the stability of spectral signatures, the predictable patterns of brightness variation all suggest internal processes that regulate output rather than simply responding to external heating. Natural comets display chaotic, irregular activity as different regions warm and cool unpredictably. Atlas maintains an almost mechanical precision that feels engineered rather than evolved. The size uncertainty that continues to plague our observations serves multiple purposes, whether intentional or coincidental. The persistent coma that shrouds the nucleus makes detailed structural analysis impossible while creating perfect camouflage for whatever lies beneath. We can study the envelope, analyze the emissions, track the motion, but the actual object responsible for these phenomena remains hidden behind veils of its own creation. This concealment extends beyond mere visual obstruction into realms of strategic ambiguity that serve intelligence-gathering purposes remarkably well. If we cannot determine the true size and structure of Atlas, then we cannot assess its capabilities, cannot predict its potential actions, cannot even be certain whether we're dealing with natural debris or sophisticated technology. The uncertainty itself becomes a form of protection. ensuring that any response we might consider remains necessarily limited and cautious. The thick disk origin traced by Atlas's trajectory adds temporal dimensions to these mysteries that stretch beyond human comprehension. If the object truly comes from that ancient stellar population, then it carries within itself the legacy of epochs when our galaxy was younger, more violent, more chaotic. The survival of any construct across such vast spans of time suggests either impossible luck or impossible engineering, preservation methods that transcend our current understanding of materials science and systems design. Such longevity implies purposes that operate on timescales beyond individual civilizations, beyond individual species, perhaps beyond individual stellar generations. What motivates intelligence to launch missions that will unfold across billions of years? What information justifies journeys that span galactic rotations? What patience allows consciousness to plan for outcomes that will occur long after the planners themselves have passed into cosmic history? The answers might lie in concepts of galactic management that make planetary ecology seem trivial by comparison. If advanced civilizations view the Milky Way as a single integrated system, they might deploy monitoring networks that track the development of countless worlds across cosmic time. Individual objects like Atlas could represent nodes in a surveillance grid so vast and so patient that entire species rise and fall between data collection cycles. From such a perspective, humanity's recent emergence as a technological civilization might represent not a unique event worthy of special attention, but a predictable milestone in processes observed countless times across the galaxy. Our radio emissions, our space exploration, our global industrial footprint, all could be familiar signatures that trigger routine surveillance protocols established billions of years ago by intelligences whose purposes we cannot begin to imagine. The biological implications of Atlas's passage continue to hover at the edges of legitimate scientific concern. Too speculative for formal research, yet too plausible for complete dismissal. The object's emissions create expanding clouds of material that Earth's orbital motion carries us through repeatedly, exposing our atmosphere to whatever microscopic passengers might be riding along with the more obvious chemical signatures our instruments detect. If Atlas carries biological agents, whether natural spores preserved from ancient environments or engineered organisms designed for specific purposes, then our encounter with this interstellar visitor becomes potentially transformative in ways that operate below the threshold of immediate detection. Such agents could remain dormant for generations before activating, triggered by environmental conditions or population thresholds that represent optimal timing for whatever effects they were designed to produce. The dispersal mechanisms operate on scales that dwarf human ability to monitor or contain. We cannot quarantine our planet against microscopic invaders, cannot screen our atmosphere for biological agents designed to remain hidden among the cosmic debris that constantly rains down upon us. Even if we suspected such contamination, our ability to detect and identify alien biology remains primitive compared to the sophistication such agents might represent. The international response to Atlas reveals humanity's fundamental lack of preparation for scenarios that transcend traditional categories of natural phenomenon and artificial threat. Different nations monitor the object according to their own priorities and capabilities, sharing data through scientific channels designed for benign curiosity rather than potential reconnaissance or intervention. No coordinated planetary response protocols exist for encounters that blur the boundaries between astronomy and intelligence gathering. This fragmentation extends beyond mere organizational challenges into realms of strategic vulnerability that any observer would note and catalogue. Our divided response to Atlas might reveal more about human civilization than any deliberate communication we could attempt. The lack of unified protocols, the absence of coordinated analysis, the reliance on academic rather than security-focused evaluation, all could be interpreted as evidence of species immaturity or dangerous unpredictability. The psychological weight of these possibilities grows heavier as Atlas continues its passage through our cosmic neighborhood. Each observation that supports natural explanations provides temporary comfort. Yet each anomaly that resists such explanations deepens the underlying unease. The ambiguity itself becomes a kind of psychological pressure, forcing humanity to confront limitations in our knowledge and capabilities that we might prefer to ignore. The speed at which Atlas moves through our solar system adds urgency to these concerns, while simultaneously limiting our options for response. We cannot intercept the object, cannot alter its trajectory, cannot even extend our observation window beyond the constraints imposed by orbital mechanics and the inverse square law of electromagnetic radiation. We are spectators to an encounter whose significance we cannot determine and whose outcome we cannot influence. This helplessness might itself be part of the phenomenon we're trying to understand. If Atlas represents reconnaissance, then our inability to interfere with its mission becomes a crucial data point about human technological capabilities and strategic readiness. The demonstration of our limitations might be as valuable to potential observers as any information they gather about our world and our civilization. The departure of Atlas will leave us with questions rather than answers, speculation rather than certainty, possibilities rather than proof. But it will also leave us permanently changed, forced to consider that our cosmic isolation might be an illusion maintained by watchers whose methods are sophisticated enough to observe without being observed, to study without revealing themselves, to gather intelligence while appearing as natural phenomena we're comfortable dismissing as merely curious rather than potentially significant. The worst-case scenarios we've explored throughout this gentle journey don't require dramatic revelation or obvious intervention. The worst case might simply be the gradual realization that we exist in a universe where intelligence operates on scales and through methods that make human technology seem primitive by comparison, where surveillance might be constant yet invisible, where our development as a species unfolds under observation by consciousnesses whose purposes and capabilities remain forever beyond our comprehension. As Atlas fades from our telescopes and disappears back into the vast darkness between the stars, it carries with it whatever secrets it possessed, whatever data it collected, whatever conclusions it might have drawn about humanity and our place in the cosmic order. We are left to wonder whether we witness the passage of exotic natural chemistry or sophisticated artificial intelligence, cosmic coincidence or calculated reconnaissance, absent companionship or present surveillance that succeeded so completely in its concealment that we mistake observation for solitude. The questions raised by this strange visitor will persist long after the object itself has vanished beyond the reach of our instruments, becoming permanent features of human consciousness as we struggle to understand whether we are alone in the universe or simply alone in our awareness of company that has been with us all along. In the end, perhaps that uncertainty itself represents the most profound communication we could receive from intelligences advanced enough to understand that some truths are too transformative to reveal directly, that some knowledge can only be approached gradually through gentle questioning rather than dramatic revelation. Tonight, as you drift towards sleep with these cosmic mysteries flowing through your thoughts like starlight through space, consider that the universe might be far stranger, far more populated, and far more carefully orchestrated than we've ever imagined. The silence that surrounds us might not indicate emptiness but fullness, not absence but presence so sophisticated that it operates invisibly within the very phenomena we consider most natural and familiar. And in that possibility lies both comfort and unease. The knowledge that we might never be truly alone, coupled with the recognition that we might never be truly certain whether our solitude is real or simply the most elegant illusion ever crafted by minds whose patience spans the ages and whose purposes remain as mysterious as the darkness between the stars. As we draw near the end of our gentle exploration of Atlas and its mysteries, there's one final consideration that whispers at the edges of our cosmic contemplation. Perhaps the most unsettling aspect of this entire encounter isn't what we've discovered about the object itself, but what it reveals about the fundamental nature of knowledge and certainty in a universe that might be far more layered than we've ever imagined. Throughout human history, we've found comfort in categories. Things are either natural or artificial, random or designed, present or absent. These distinctions help us navigate a complex world, providing frameworks that make sense of phenomena we encounter. But Atlas refuses to fit neatly into any of these comfortable boxes, existing perpetually in the spaces between certainty, in the grey areas where our categories break down and our assumptions begin to feel inadequate. This refusal to be categorized might itself be the most significant aspect of the entire encounter. Not because Atlas is necessarily trying to confuse us, but because confusion, uncertainty, and the persistent inability to reach definitive conclusions might be unavoidable features of any contact between intelligences operating on vastly different scales of time, space, and comprehension. Consider how this dynamic might play out across the galaxy. If advanced civilizations do exist, if they do monitor younger species, if they do occasionally intervene in planetary development, then the evidence for such activities would necessarily remain ambiguous to those being observed. Clear proof would defeat the purpose of subtle influence. Obvious surveillance would contaminate the natural development processes being studied. The most effective observation would always appear natural to those being observed. This creates a kind of permanent epistemological prison for emerging civilizations like our own. We become capable enough to detect anomalies, to notice patterns that don't quite fit natural explanations, to suspect that something more complex might be occurring around us. Yet we never become capable enough to prove these suspicions, to move beyond speculation into certainty, to definitively answer the questions that our growing awareness inevitably raises. The result is a state of perpetual uncertainty that might itself be intentional, designed to prepare us gradually for realities we're not yet ready to confront directly. Each anomalous visitor like Atlas pushes us a little further along a path of questioning and speculation, expanding our conceptual frameworks, challenging our assumptions about cosmic solitude, preparing us for eventual revelations that might otherwise prove too shocking or too transformative for unprepared minds to handle. From this perspective, the ambiguity surrounding Atlas becomes not a failure of our scientific methods, but evidence that those methods are encountering phenomena designed to operate at the very limits of our understanding. We're being challenged to grow, to expand our thinking, to develop new ways of processing information that doesn't fit comfortable categories. The uncertainty itself becomes a form of education, teaching us to live with questions that have no easy answers. This educational interpretation extends beyond individual objects like Atlas to encompass the broader pattern of anomalies that have begun appearing in our skies with increasing frequency. Each interstellar visitor brings new puzzles, new challenges to our understanding, new evidence that the universe might be far more complex and far more carefully orchestrated than our current theories suggest. The accumulating weight of these encounters gradually reshapes human consciousness, preparing us for eventual contact with intelligences we're not yet ready to recognize directly. Yet there's also the possibility that we're reading too much significance into phenomena that are genuinely natural, that the patterns we perceive are products of our own psychological need to find meaning in randomness rather than evidence of external intelligence or intervention. The human mind excels at detecting patterns, sometimes to the point of perceiving design where none exists, purpose where only chance operates. intention where only natural processes unfold according to physical laws. This uncertainty about our own perceptions adds another layer of complexity to the entire encounter. We cannot trust our interpretations completely because we know our minds are biased toward finding significance in ambiguous data. Yet we cannot dismiss our observations entirely because genuine anomalies do require explanation, and some explanations inevitably lead toward possibilities we find uncomfortable to contemplate. The departure of Atlas will not resolve this fundamental uncertainty, but will instead add to the growing collection of cosmic questions that seem designed to remain unanswered. Future interstellar visitors will likely present similar challenges, similar anomalies, similar blends of the explicable and the mysterious that keep us suspended between natural and artificial explanations without ever providing definitive resolution in either direction. This permanent suspension might represent the natural state of emerging civilizations in a galaxy where intelligence operates on multiple scales simultaneously. We exist in a kind of cosmic adolescence, old enough to begin asking the right questions but too young to handle the full implications of the answers. The ambiguity that surrounds objects like Atlas might serve as training wheels, keeping us balanced while we develop the wisdom and maturity necessary to engage with cosmic realities we cannot yet fully comprehend. And so, dear sleepy travelers, as Atlas fades beyond the reach of our telescopes and disappears into the cosmic dark, we're left not with answers, but with something perhaps more valuable: the gentle expansion of our cosmic perspective and the quiet recognition that the universe might be stranger, more populated and more carefully orchestrated than we ever dared imagine. Whether this mysterious visitor carried exotic chemistry from ancient stellar nurseries or represented our first glimpse of intelligence so advanced we mistake it for nature itself, it has already transformed us, leaving us forever changed by questions that may be more important than any answers we might eventually find. Sweet dreams, and remember that in a cosmos full of mysteries, sometimes the most profound discoveries are the ones that teach us how much we still have to learn. Boring Science Channel here. See you in the next one.